So the first topic that we will study, that is binary operation. Like, what is binary operation? I told you that in our GATE syllabus we have algebraic structure with one binary operation. But what is binary operation? So that we need to study. Let's see what is binary operation and the closure property. So first we will study what is closure property. Then I will tell you what is the definition of binary operation. What is this closure property? See, the definition of closure property is very simple. So you have, let's assume you have a set. You have a set. So this is your set. Let's assume this is your set. In this set you have some elements. Now on this set you are, okay, let's assume you have this set as, on this set let's assume you have some operation. You define some operation. Now when can I say that this structure, this is a structure, remember, correct? This is called structure. I told you this is your algebraic structure. Now when can I say that this structure will satisfy closure property? When can I say this structure will satisfy closure property? Closure property basically means that whatever happens inside, this is your set, whatever happens inside, that will stay inside this. Means if you take any two elements, arbitrary element a comma b, if you take, you apply the operation, you apply this operation on any two elements of this set. So from this set you take any two elements, you apply this operation, the result should belong to this set. The result should belong to this set. This should happen for all a comma b. Whatever a you take, whatever b you take, then what should happen? The result of this operation should be in this set. In this situation, so this result, remember this C is the result. So I can say in this situation, I can say that I will say that this structure will satisfy closure property. Then in this situation, we will say closure property is satisfied. Closure property is satisfied by this structure S comma hash. So this structure will satisfy closure property. Is this definition clear? Tell me. The definition is very simple. Basically, closure property means if the result of operation, you perform the operation and the result of operation always is element in the set, then we will say that this set is closed. Then we will say that this set is closed under this operation. Or I can say this structure has closure property. So okay, so this set has closure property under this operation. This is the definition of closure property. So I can say that closure property basically means, this basically means what, okay, you can think like this: what happens inside a set should remain inside a set. Okay, so this is the definition. Remember, we are only taking one operation, because in the GATE syllabus I told you we have only a set and single operation. So you have set, for example, let's assume you have this set and this operation, addition operation you have. Now tell me, will it satisfy closure property? Yes, it will satisfy closure property, right? So this structure will satisfy closure property, I can say. Closure property will be satisfied. Why? Because remember, if you take any two natural number, take any two natural number for all a comma b. If you take any two natural number from this natural number set, remember this is your natural number set. Here you have 1, 2, 3, 4 and so on. Now take any two natural number, and then you perform this operation. Can I say the result will be natural number? Tell me. Can I say the result? Can I say this result will be natural number? Yes, this result will also be natural number. Natural number plus natural number, the result is also natural number. So that's the idea. So if you take any two, whatever two, that is your choice. Whatever two natural number you take, then what can I say? I can say a plus b is also natural number. So the closure property is satisfied. I can say that this set of natural number is closed under addition. Okay, so this is what I can say. I can say this set of natural number is closed under addition operation. Okay, next example. Can anyone tell me, is this set closed under addition operation? 1, 2, 3. Can I say this set is closed under addition operation? Is it closed? Will it satisfy closure property? It will not satisfy closure property, right? It will not satisfy closure property because remember, closure property says that what happens inside this set should remain inside this set. But you cannot see, if you take these two elements, and you perform the operation, then the result will be 5. The result will be 5, and you can notice this 5 is not in the base set. The result will be 5, and 5 is not in our base set. Correct? Okay, so the result is not in our base set. Tell me. Okay, can I say that 1 plus 1 is equal to 2 and this belongs to base set? Then can I say closure property satisfied? If I take 1 comma 1, if I take, let's assume I take a equal to 1, b equal to 1. Now tell me, can I say closure property is satisfied? No, remember, it does not mean closure. This thing does not mean closure. This does not imply closure, because closure property says that whatever any two elements you take, whatever two elements you take, their results should be in the set. So this does not imply closure property. Okay, I hope this point is clear. Okay, tell me about this one. If I give you this set, true comma false, if this is your base set and the operation is conjunction, is this closure, will it satisfy closure property? Will this satisfy closure property? Yes, this will satisfy closure property, right? This will satisfy closure property, because any two elements you take, you can take false, false, the result is false. Oh, and you can notice this belongs to base set. What is your base set? Can anyone tell me what is the base set? The base set is true comma false. This is the base set. So whatever two elements you take, same or different, whatever two elements you take, you can notice that the result belongs to base set. Any two elements you take, the result belongs to base set. So whatever two elements you take. So finally, I can say that any two elements you take, you remember, you can take same element or different element, like you take FF, like you take FT, like you take TF, like you take, okay, TT. So whatever two elements you take belong to the base set. So I can say that this will satisfy closure property. What about this one? Set of natural number comma subtraction. Will it satisfy closure property? Is this closed? Can I say this is closed? No, the answer is no. This is not closed. What is, because you can see, this is your set of natural number 1, 2, 3, and so on. If I take two numbers, let me take these two numbers, like 1, 5, let me take 1, 5. Now if I apply the operation, the result is -4. The result -4 is not in set of natural number. This is not in set of natural number. Or you can see another example you can do is 1 minus 1. You can take these elements 1 minus 1. The result is 0, and 0 does not belong to natural number. Correct? Yes or no? So I can say closure property is not satisfied. What about set of whole numbers? Set of whole numbers comma subtraction. What about this? Here also closure property is also, this is also not closed. Is it closed? No, this is not closed, because the same logic. Here you can notice that if you take the two elements, let me take the two elements, like if let me take a equal to 1 and let me take b equal to 2, then you can clearly see that 1 minus 2, this is -1, and this is not whole number. So this is the idea of closure property. Okay, so closure property means whatever happens inside a set should remain inside the set. So formal definition, if you notice, formal definition, what is that? So you have a set. So let's assume you have a set. This is your base set S, and you have this binary operation, this some operation you have. Let's assume this operation hash you have. Then in this case, will satisfy this thing. This is called algebraic structure. I told you, this is known as algebraic structure. This is your algebraic structure. So this algebraic structure will satisfy closure property. Will satisfy closure property if and only if, will satisfy closure property if and only if for all a comma b, whatever two elements you take, for all a comma b, from this base set, whatever two elements you take, for all a comma b, what should happen? A hash b should belong to S. So this is the definition of this closure property. So now you can notice integers are closed under operation addition. Yes, because integer plus integer, that will be integer. Integers are not closed under division operation, right? Yes or no? Set of integers comma division operation, this is not closed. I can say this is not closed, or I can say closure property is not satisfied. Why? Because if you take these two elements, like take a equal to 2 and take b equal to 3, now you can clearly see that a divided by b, what is that? That is 2 divided by 3. Okay, and this is not integer. So this is not an integer. Similarly, the set of rational numbers, they are closed under operation of multiplication, because if you take two rational number, their multiplication also will be the rational number. Similarly, natural numbers, they are not closed under the operation subtraction, we have already seen. This set is not closed under the operation addition, because you can notice 2 plus 3, that is equal to 5, and 5 is not in the base set. If I give you this base set and the operation is addition, is it closed? Is this closed? Tell me. This is not closed. Again, this is not closed. So your base set is this. Your base set is this. This is your base set. In your base set, only this element you have. Now, is it closed? No, because if you take this a comma b, then the result does not belong to the base set. Okay, is it clear? So because remember, this is the base. Remember, element is this. Element is this. Many students are thinking that this is the element. This is not the element. This is the base set. Element is this. Is it clear? This is not the element. Element is this. This is the base set. Okay. And what about this one? Is it closed? Like if I give you 0, comma addition, is this closed? Yes, this is closed. This is closed because if you take 0 plus 0, the result is 0, and this belongs to base set. So this is closed. Now let's move on. Now let me tell you that sometimes this structure, if you have, okay, this structure that you have, if I give you this structure, for example, let's assume I give you this structure, maybe some structure I give you like a b and operation is star. Let's assume some star operation I give, and let's assume that this is closed. Let's assume this is closed. Then what I can do, I can represent the this structure by a table, by a operation table. For example, what I can do like this, a b, and let's assume I write like this. Tell me what it means. So basically, this structure I am representing by this table. This table is called operation table. This table is called operation table. And what this table means? What this table means? So just understand what this table means. This table means that always this table means like this: a star a. Okay, okay, like do like this: a star a, that is a. It simply do like this: a star a. Similarly, a star b, that is b. A star b, that is b. B star a, that is a. B star a, that is a. B star b, that is a. Okay, so this is how you can read the operation table. Remember, whenever you read the operation table, always read from row. Like, okay, so what this means? Let's see what this means. What this means? Can anyone tell me? Does this mean a star b or b star a? What this means? This means a star b or b star a. What this means? This means a star b. This does not mean a star b, b star a. Okay, so always read. Whenever you have this operation table, always read from row. Okay, always read from left to right. So this means a star b. A star b is equal to b. Okay, a star b is equal to b, because you can notice that b star a is equal to a. So you can notice b star a is equal to a. So here a star b is b and b star a is a. So this is how you can read the operation table. Now tell me, this is your operation table. Is it closed? Is it closed? So this is your base set A, B, C, D, A, B, C, D, A, B, C, D. Will it satisfy closure property? Is this closed or not? This is the question. You can very easily see your base set is A, B, C, D, and all the results are A, B, C, D, right? All the results are A, B, C, D. So yes, this is closed because all the results are A, B, C, D. For example, can anyone tell me what is A star E? What is A star E? A star E is D, because this is A, this is E. A star E is D. Can anyone tell me what this means? What this means? This means a C star D. C star D is equal to E. Anyway, the point is that every result is in the base set. Okay, let's make the operation table for this. 1, 2, comma addition. So can you make the operation table? Make operation table. So how will you make the operation table? The operation table you will make like this: 1, 2, 1, 2. Now the operation is plus. This is the operation. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. 2 plus 2 is 4. Is it closed? Clearly this is not closed. Clearly this is not closed, because you can notice this is the base set. Our base set is 1, 2. So clearly you can notice that this is not closed. Okay, so I can say this is not closed. This structure is not closed. What about this structure on your screen? Is this structure closed? This is the base set. Base set is A, B, C, D. But you can notice the result is H also. So this is not closed. Because you can notice that here you can notice what is A dollar. The operation is dollar here. Operation is dollar. So what is A dollar E? A dollar E is H. And this is not in the base set. We don't have this in the base set. So I can say this is not closed. So not closed. Okay. Now the next thing, what is the definition of binary operation? What is your intuition for the binary operation? Anyone? What is your intuition for the binary operation? Like, see, in general, remember, in general, when I say binary operation, in general mathematics, when we say binary operation, or in computer science, I can say, in general computer science, if I say binary operation, what this means? This binary operation, this word means two things. Binary operation basically means two operands. We need two operands. If I say that this is the binary operation, then it simply means two operands. For example, this addition, this is the binary operation. For example, this multiplication is the binary operation. Okay, so basically we need two things. We apply this on two things. Then this is called binary operation. Like, what is unary operation? Unary operation means basically one operand. For example, -2. Here only one operand we have. Here only single operand we have. Only one operand we have. This happens in the general computer science. Okay, like ternary operator. Can anyone tell me the example of ternary operator? Ternary operator. Anyone? Ternary operation. What is the example of ternary operation? Yes, this is the example in C programming. You study this. This is the example of ternary operation, right? For example, A. This is the example of ternary operation in C programming. Okay, so now you can notice one thing. This is what happens in the general computer science. But in abstract algebra, binary operation has a different definition. So let me tell you that in abstract algebra, whenever you study abstract algebra, in abstract algebra, binary operation has a different definition. Binary operation, what is binary operation? Yes, it will apply on two operands, that is fine. Binary operation hash. What it means? It will definitely apply on two things. So you must have this, you must have this, that is fine. But there is one more issue. There is one more issue. We will say that this is binary operation if and only if closure property is satisfied. Okay. So binary operation in abstract algebra, binary operation simply means that closure property. Binary operation simply means closure property. So this is the point that I can finally say these two things are same. If I say that if I want to say that hash is a binary operation, if I want to say this, hash is binary operation on set S, then what it means? On set S, hash is binary operation on set S. This automatically means if and only if S comma hash satisfies closure property, is closed, is closed. Means if and only if this will satisfy closure property, then we can say that this is the binary operation. So this is the difference. Okay, this is the difference. Very small difference. So basically binary operation, when can you say that this is a binary operation? Binary operation simply means closure property, that's it. So if you have a set, then when can I say that it is a binary operation? You have this set, let's assume you have this set G and you have this operation. Then this star is binary operation. Star is a binary operation if and only if. Star is binary operation if and only if. What will happen? For all A comma B, whatever two elements you take, what should happen? A star B should belong to G. For any two elements, whatever two elements you take, A star B, that should belong to G. So binary operation, another name is closed operation. That is the reason this binary operation, another name of binary operation is closed operation. In abstract algebra, another name of binary operation is closed operation. Okay, is this definition clear? So I can say that, can I say this addition? This addition is binary operation on 1, 2. Can I say this is binary operation on 1, 2? Can I say this? This addition is binary operation on 1, 2? The answer is no. The answer is no. But you can notice that addition is binary operation. This is binary operation on set of natural number. Yes. Okay, I hope this is clear to everyone. So what is binary operation? Now just let me tell you final thing. All the structures that we will study, they are closed. All the structures that are interesting, every structure that is interesting, that is closed. So let me just change the definition of this algebraic structure. What is the definition of algebraic structure? Let me tell you. In algebraic structure, it must be closed. Remember, okay, algebraic structure by definition it must be closed. By definition it must be closed. By definition must be closed. Must be closed. That's it. So for example, yes, this is a algebraic structure. This is algebraic structure. Tell me, set of integers comma, this is closed or not? Tell me, is it closed or no? Yes, this is closed, right? This is closed because if you take any two integers, a comma b, if you take any two integers, then what will happen? Take any two integers, then a minus b definitely will be integer, right? You can take any two integer. For example, 2, 3 you can take. Okay, then this will be integer. This is integer. You can take 3, 2. The result is also integer. So whatever two elements you take a comma b, for all a comma b in integers, a minus b is integer. So I can say yes, this is closed. So because this is closed, so I can say this subtraction is binary operation. So I can say this subtraction is binary operation on set of integers. I can also say that this is algebraic structure. I can also say that this is a algebraic structure. So all these three things are same.